Good afternoon, everyone. My name is Betty Emmanuel. As you can see, it's right there. And today we are going to discuss about how to incorporate explainable and responsible AI in search algorithms. So in the next slide, I'm going to give you a brief overview of AI, what is AI, and how it is being used in today's world. So without wasting time, let's go to the next slide. What is AI? What comes in your mind when we talk about AI? AI stands for artificial intelligence, and it refers to the simulation of human intelligence processed by a machine. Based on our context, AI is used in various applications, especially in search algorithms for the fields like robotics and healthcare. So, in order to incorporate explainable AI and responsible AI into these algorithms, you must ensure that first of all there is transparency, secondly there is accountability, and lastly there is fairness. So, in the next slides, I'm going to give you a brief explanation of what is explainable AI and also responsible AI. Let's go to the slide. Explainable AI, it ensures that the AI decisions are transparent and also understandable by a human being. Whereas responsible AI, it focuses on fairness, accountability, and privacy. The next slide, I'm going to introduce you later what is all about uniform search algorithm. So let's go to the next slide and we explore more about it. Uniformed algorithms such as wealth fast search, which is also named as BFS, and also we have depth fast search, also named as DFS. They both operate without specific knowledge of the goal. So in the next slide, I'm going to give you a brief overview, a brief definition how the BFS and the DFS work. So let's go to the next slide and we explore more using administration what I have provided. So here we have depth first search algorithm. So what we have to know about the DFS is it is an algorithm for transversing. That means we have this tree, what you can see here. We have this tree, and we have our starting point, which is S. As it is the DFS, we are going to deal with the left side. That means everything what we are going to do it is going to be in the left side. So let's start by understanding how this tree is done. So first of all, we have our starting point, our starting point, our starting root, what is S, our node. Then we go to the node A. What is the next node? And after reaching the node A, we go to the node B. And after reaching the node B, you can notice that we have two more nodes. We have node C, and node G. As I said earlier, that when you are dealing with DFS, everything what you are doing has to be in the left side. That means instead of taking G, we are going to go with C. So after reaching C, we only have one more node remaining, which is node G. That means that's where the first search algorithm stops. So let's go to the next slide and we explore all about the breadth first search algorithm, or the BFS. Here we are. BFS as it's also a type of algorithm, and here we are basically going to do everything on the right side. That means we have three nodes from the starting node, which is S, to the G, which is our last node, and that's how it occurs. We start by our starting point, our starting node, which is S, then we go to D. And after reaching D, we only have one node, and we directly go to node D, and that's where our breadth-first search stops. So this is all about the DFS and also the BFS algorithms, incorporating explainable AI and responsible AI into informed search. Before incorporating the explainable AI and responsible AI, you have to make sure that you have this key point: the accountability and decision-making openness. The second point is about the traceability and the logging. And the last point is ethical consideration. So the next, point is going to be about informed search algorithm, which is also a later, which we are going to discover as we are going deeper. Informed search algorithms. Informed algorithm like Esther and gradient-based first search uses heuristics to optimize search processes. So the next slide, I'm going to briefly explain to you. What is Esther and gradient-based fast search algorithm. So let's go to the next slide. The next slide says, what is Esther? What is a Esther algorithm? Esther, it is an algorithm. It's mostly used in applications, computer games, and in the computer games. The second major point about the informed search algorithm is the gradient-based fast algorithm, and this one is also another type of algorithm, but this one is basically in charge of organizing the nodes. Like how we see earlier, we had node S, and after node S we have after node S. Now you have to be specific on what type of algorithm you are dealing with. If it is DFS, that means you're going to deal with the left side. If it is the BFS, that means you're going to deal with the right side. How do we incorporate explainable AI and responsible AI into form search algorithms? These are the key points. First of all, we have heuristic justification and the impact assessment. Second point is fairness and bias auditing, and the last point is governance and ethical oversight. Before summing up our tutorial, let's first go through Python code. It is all about the BFS and the TFS and the BFS. So without wasting time, let's navigate on the browser and we explore much about that viewing code. So this is the code what we have here. So here I started by creating a function, and that function has two parameters: the node name and the value. And if that function is true, we are going to print the node name and its value. So as I showed you earlier, the starting point was s. The same thing here. So s has a value of 1. So here we print the value of s and it is 1. As you continue going deeper, you're going to see that it keeps on adding 1 over time. So here is a function created for node A, what has input value S. So that means the value of S plus 1, it is 2. You can see here the same concept goes to node B, and so on. Let's also have a look at how BFS is being implemented in a real world, because the first one was about the DFS. So it's frozen. So this is the code of BFS algorithm, and yeah, as we can see, we have our first function, we'll check the node name, and it has two parameters, the node name and the value, as we previously discussed on the DFS. So it has two parameters, and if true, it prints the node name and its value, as we have seen. We have seen in the illustration that the BFS has only two nodes, starting with C, which is our root node, and we also have the node D, and lastly we have node G. So as we can see here, this is the same concept, but only this one, it is based on the right side. Our starting point, which is S, as 1 as value, and it returns the value, which is 1. Also, the node name, which is S, and so on. So this is all about BFS and GF8. So as we are summing up our work, conclusion. This is our conclusion. Incorporating explainable AI. So this is our conclusion. Incorporating explainable and responsible AI principles ensures that transparency, accountability, and also ethical use of both uniformed and informed search algorithms. Thank you for watching my video, and don't forget to subscribe, and let's meet in the next video.